Welcome to this talk. Today we will be talking about how we will minimize and optimize the re-rendering of React components. We all know that when a component which is deeply nested re-renders will take some time and a lot of computational work. However, JavaScript is a single-threaded programming language and it will be all done on our main thread. So when the rendering will happen, it will completely block our main thread and preventing our users to do some interactions with our app and leaving a very bad experience for that. So there are some few optimization we can do to minimize this. The first optimization is should component update. Now what should component update we will see. For this session I have created a project. As we can see here, it is a very simple React app project. It is a wall, and wall consists of several bricks. Every brick has a name and an ID associated with it, and if I select a brick, it will get selected, and if I again click on it, it will get deselected. Now if I look on the code, this is the wall code. Wall is a React class component. It consists of an array of bricks with every brick has an own ID and name, and I have rendered loop through that array of bricks and rendered it on the screen. Every brick has its own key ID and a selected property that whether the brick has been selected or not. And if I check the brick code, brick is also a React class component, and that's all. Now let's see what is going on. Yeah. If you go in the inspect mode, if I refresh our app, see we can see in the console that every brick has been re-rendered from brick A to brick R up to brick R. Every brick has been initially rendered on the screen. Now what we can see that after clearing the console, if I click on any of the brick, say suppose G, if I click on the brick G, it should get selected and only this component needs to be updated because I have clicked upon the brick G. Let's see what happens. If I click on brick G, we can see here that every component is re-rendered again, because as in the console we can see that brick rendered A, brick rendered B, every brick is being re-rendered. Now if I click on another brick C, see again a full list of all the components which are being re-rendered. But why is this happening? I am clicking on a specific brick and every component, every brick is being re-rendered. So by default, brick is a React class component, class based component, so it doesn't have any optimization. So to make this prevent this re-rendering happening, we will implement should component update. Now one thing to note, should component update is a lifecycle method provided by the React, and it is only available on class based components. Since brick is a class based component, we can apply should component update here. Should component update is always executed before the render method. If should component update returns true, it means the re-rendering needs to be done for that component. If it returns false, then the re-rendering of that component will be stopped. If you can write should component update, it accepts two parameters. Next props, comma next state. Now here we will check if the selected prop of my component is different from my previous selected prop. Now we can write a condition here: if next props dot is selected is not equal to this props dot is selected. What am I checking here is that suppose previously my brick was not selected, my is selected prop was false. Now if I click on that brick, the is selected prop should change to true. So my current prop is true and my next prop, sorry, my current prop is false and my next prop should be true because it gets selected. So both the props should not be equal, then only we have to re-render this component. So in this check condition we will return true, else return false, and only this single optimization will see something which is happening. Now if I refresh the app, we can see that every component is rendered from starting brick A, from brick A to brick R. We're clearing the console. Now if I click on the brick G, see, only brick G is now re-rendered, not every component. This, the optimization what we have done here using shouldComponentUpdate, lets this happen. It's a small app, so it doesn't affect much time. But in cases of large apps or production apps, every bit of time what we can save, it lets a very good user experience to them, because it doesn't block the main thread. The re-rendering part doesn't block the main thread part. So now we have learned shouldComponentUpdate. Note that shouldComponentUpdate is only a lifecycle method on a class-based React component, not for functional React components. Okay. Next thing we're gonna learn about pure components. What are pure components? So when we write a class-based React component, we always write class brick extends React.component. It indicates that this class is a simple React component. But React has also provided another type of component which we can write as pure components. Instead of extending from class brick extends React.component, we're gonna extend it from pure component. Now what a pure component does. So pure component by default contains a shouldComponentUpdate, which checks from previous props as well as previous state to the next props and next state. If the previous prop is not equals to the next props, it gonna re-render, or if the both are same, it will not re-render. So if I comment out this line of code, I'm gonna remove it. Without this shouldComponentUpdate, it is having by default the shouldComponentUpdate method lifecycle on it, because now it is a pure component. Pure component means it will only re-render if the props on the state has been changed at the time of re-rendering. Okay. Now if I gonna save that and refresh my app, every brick is being re-rendered from A to R. If I click on brick B, see, now only brick B is re-rendered, not everything. That's the beauty of pure components. It gives the shouldComponentUpdate part of code by default in it. We can also use shouldComponentUpdate here to check some other conditions on it. But instead of writing shouldComponentUpdate, we should use pure components if we don't have to write everything on our own. So we're gonna move to the next thing. The next thing is we're gonna run Memo. So until now we have learned that we have done everything optimization for a class-based React component. So what about functional components? In React we have two types of components, a class-based component and a functional components. So what should we do for functional components? Because it doesn't have any lifecycle methods on it, so we can't apply shouldComponentUpdate on it, or we can't extend it because that's not a class, it's a function. So first I will make this break component as a functional component. Let's see what happens. Const break. It will be props, accepting as a prop. Remove the render method. Now moving to this. Now it's now a functional component. So if I re-render my app, I can see everything is being rendered. Now my app is without any optimization. If I click on brick G, now everything is being re-rendered again. So to prevent this, we will use Memo. React provide this by default. Now to import this, we will import Memo from React, and now Memo will wrap our functional component in Memo. By default, Memo accepts two parameters. First one is the functional component which you have created, and second one, function. Should it update? I have not created that function yet, but if I create it, const should it update. If this function returns true, then this functional component which you have wrapped in Memo will be re-rendered again. If it returns false, then it will not re-rendered again. Okay. So should component update will take next props and it will receive current next props and current props. So if we check here, again we will check if next props dot is selected not equals to current props dot is selected, then return true. I need to re-render this, else return false. So you can see we have written our own condition. This function will receive two parameters, which will contains the first one contains the next props and second one contains our current props. We will checking that if the next props which are received by this parameter component is different from our current props, then we will notify the Memo that we need to re-render this component. But I have checked a single parameter on this next prop.x selected, but by default if I don't give this function, Memo will what Memo will do, it will check every props in it from my previous props and my current props, and it will compare both of them. If they are equal, it will not re-render this component, else it will re-render it. If my current props and my previous props are different from each other, Memo will re-render by default. Okay, so first we will not give any extra is second parameter, and if I run this component on my app, my every brick is being re-rendered from A to R. Okay, if I click on brick G, see, now only brick G is being re-rendered, not every brick. So this goes for functional components. Now we have used Memo to optimize the re-rendering. If I give should it update, if I refresh my app, it will do the same thing as it has done before, because by default it will check every props, and if I in this function I am checking only a single prop. If this has been different from my current props, then only re-render this component. So if I click on G, okay, something is not happening here. Return props, next props. Okay, we're gonna console it. We're gonna log my next props and current props. Okay, now if I refresh and click on it, okay, I see is selected is undefined, and on brick tool is undefined. Now why is this happening? Okay, let me check the documentation of shouldComponentUpdate. We will run the React.js shouldComponentUpdate in action. Okay, here we got it. shouldComponentUpdate receive next props as well as next state. Okay, sorry, we are checking here. Memo, sorry, React dot memo. My second are equal. Okay. Prep props and next props. Return true if the passing next props to render. Okay, we are doing the same thing now. Next props. Okay, these are actually my pref props and next props. Okay, it will be like this. First parameter will be my current props. Will be next props. Okay. So if I return this back to our component, nothing happens. It's the same. Is selected undefined. Is selected undefined. Why is this happening? Let me check. Why is this happening, man? Are equal my component. Okay, something we gotta. So now, okay, according to the documentation, we're gonna see that if we're gonna re-render this, if the props are equal or not. Are they equal? Okay, the function name should be are they equal. Now what this function does, if my current props as well as next props are equal, if we return true, it will not re-render this, and if they are not same, we will return false. If you return false and here return true, it means if they are not equal, the props are not equal, are equal. Okay, now if we refresh our app, everything is being re-rendered. Okay, now if I clear the console, clicking on C, brick rendered C. See, now only my brick is being re-rendered, not everything. Now if I remove console of my next prop, okay, thing is being rendered. Clicking on brick C, now only brick C is being rendered. Brick G, brick GH. Okay, there is some confusion in it, so now the confusion is solved. Now what the problem was that it's the second parameter which the memo accepts was the equal for equality function. The equality function checks if my current props as well as my next props are equal or not. If they are equal, if it returns true, which means the prop, next props and my current props are equal, it will not re-render this functional component because the next props and my current props are equal. But what if we return false from that function? Which means that my next props and my current props are not equal. That's why we're returning false. The function name is are they equal. Okay, typo is there. Are they equal? So if are they equal, return false, which means my current props and my next props are not equal. So we need to update this component. That's how memo is used for a functional component. Okay. Now coming to our next topic, it's useMemo. What is useMemo? UseMemo is basically a React hook which helps to minimize our computational work or recalculation. Suppose we want to perform some heavy calculation upon certain conditions. Now what will happen if that calculation goes on every re-renders? When we doesn't need that, when it doesn't need it, so we need to perform that calculation only when a certain thing, certain props or certain state changes in our app. So this will be achieved by useMemo. So how we can use that? Let's take an example. Okay, suppose I'm removing this memo part to let you explain this. I will create a heavy function, const heavy function, sorry, heavy work. So what this will do, it will run a loop for int I is equals to 0 to I less than 10,000. Okay, incrementing it, and it will give us the sum. Sorry, not int. Let's sum initiate will be 0, sum plus is equals to y. Okay, it will return sum. Now if we call this function every time here, const my sum is equals to heavy work, and again console log that sum. Break sum. Now if we refresh our app, if something is missing, okay, sorry, yeah, the problem goes. Now if I refresh my app, it's taking some time. Why? The props, why it's taking so time? Okay, here we are. So we can see how much time it has taken. Every brick has been rendered, and every brick has computed its sum from 1 to 10,000. Okay, initially every brick has done it. Now we can see now my brick is not a memoized brick, which means it will re-render again and again even if its props are not being changed. So if I click on brick F, I want the heavy calculation to be done again for the brick F only, not for everyone, because its selected prop has been changed for brick F only. Now we can see here that again the heavy calculations for that component has been done, so for brick F. Okay, but what else has been done, that the heavy calculation has been recalculated again and again for every component. So how we can minimize this? So we can use here a hook known as useMemo, like the memo one which was imported from React. This is a useMemo. Use has been added to make this make the to make it as a hook, because it's a to how we can use that. So we can call useMemo. First it accepts a function, first parameter, and second parameter it will accept an array of I can say props or any value, an array of values. So if any of the value changes, it will again recompute this function which has been passed to it. So if I and I want that only if is selected has been changed for this component, then only my heavy work calculation should be done, else it should not be done. So if I see, refresh my app, initially the sum property has been calculated for every brick. Now if I click on brick G, see The sum property is only be calculated for the brick G, not for every brick. See how we can save so much of time and optimize it, and so much of computational work, making the main thread much free than it was previously, due to which you can see that my app takes so much a lot of time to re-render when I created that some functionality. Okay, what we have completed till now, we have completed the use memo. So that was it for this session. If you have any question regarding this, you can comment down below.